Hello again. In this video, I will try to solve this example where we have a 12 micro column charge is placed at the origin. A second negative 8 micro column charge is placed 1 meter to the right of the first charge. So I will consider the yellow one here is the 12 micro column, and the red spot here is the negative 8 micro column. At which location will the net electric field equal 0? Okay, so to handle such a question, we need to think about it in a logic based on the definition of the electric field. So I will say I have three different regions. I have region 1 here to the left of the 12 microcolumn, the middle between the two charges, and I have region 3, which is to the right, or at the right to negative 8 micro column. So I can say this is our 12 micro column. This is here the negative 8 micro column. The distance between them is a 1 meter. Now the key to figure out where should I start or predict the area where the electric field will be 0 between the three regions is to try identifying the direction of the total electric field in each region. So if I manage to figure out the direction of the net electric field in each region, I can tell that in this region there is a really good chance for the electric field to be 0. So if I assume this is my point 1 in region 1, which is here as my region 1, first of all, I will say the electric field generated by the 12 micro column will be going to the left, where the electric field generated by the negative 8 micro column will be going to the right. Now it might look like they are equal in magnitude, opposite in direction, but they're not, because following the concept that the relationship between the electric field and the distance, it is the squared inverse law, and because we are too close in region 1 from the 12 micro column, that will make the electric field 1 always demanding, and it will be always exist. So the net electric field in region 1 in one way or another always gonna be going kind of like to the left. So region 1 will be out of the picture because of the 12 micro column. Now let's assume in region 2 I have my test charge. It's somewhere in the middle between the two charges. Okay, and we call it this is region 2. Once again, let's identify the direction of electric field 1. Because of the 12 micro column, it will be going to the positive x-axis. For the negative 8 micro column, also will be going to the positive of the x-axis, and it is very obvious they're adding up to the same direction. That means there is no way in region 2 to have the electric field to equal 0, because they're always gonna be adding up to the same direction, will not be ever equal in magnitude, opposite in direction. Okay, let's leave us with region 3. So let's see in region 3 how we can handle it. If I put my test charge here, so it's P3 or region 3, the electric field generated because of the 12 micro column will be going away from it. That's E1, where the one generated because of the negative 8 micro column will be going toward the negative 8 micro column. Now looking at this will give us a really good chance of having a point in region 3 where the electric field of E1 and E2, they're going to be equal in magnitude, opposite in direction, and that will give us a good chance that at this position there is a chance to have the electric field total equal 0. Okay, so based on this we need to start doing our calculation around region 3 and follow the formula. So what I'll do, I will erase all these description here and start identifying the distance and few items. That's again our positive 12 microcoulomb, negative 8 microcoulomb. The distance will be 1 meter, and we said somewhere at region 3 I will have my test charge, and the distance will be, let's name it as x. Okay, now we said the electric field of E1 will be this way. The electric field generated because of the second charge, the negative 8 microcoulomb, will be this way. And we said here at this point P, the total electric field will be 0, which means E1 is going to equal E2. So K Q1 divided on R1 square, which is the distance between the 12 microcoulomb and point B, that will be R1, okay, equal K Q2 over R2, which is the distance between Q2, which is negative 8 microcoulomb, and the point B, so it is X. That will be R2. All right, let's replace the values. That's K Q1 over 1 plus X all square equal K Q2 over X square. We can eliminate the constant K. We can continue calculation a bit here. All right. So now I can place the values now. It's a 12 10 to the power minus 6 over 1 plus X square 8 10 to the power minus 6. It's all X square. We can take the micros off, do cross multiplication. That will give us 12 X square equal 8 1 plus X, sorry, square. All right, now what I'll do, I will take the square root for the two sides, and that should give me if I do the square root for 12 and also for 8, that will give me this 3.5 x, because x squared will be x on the square root, 2.8 and 1 plus x. We can expand our form. Rearrange it. That's 3.5 minus 2.8. X equal 2.8, and x will be 2.8 divided on 0.7. Doing that, it's going to give me 4 meters. So the distance between the 8 microcoulomb, the negative 8 microcoulomb, and that point B will be 4 meter. And the distance between the 12 microcoulomb and that point B will be 5 meter. This position will have a net total electric field, or the net electric field will be 0. You could try solve this problem by using the quadratic formula, which is fine, or you can do the same way I did it to solve it and find that position where the electric field will be 0. I hope you managed to think about it and figure out the logic we follow to identify which region will be the negative, and after that you can be able to do all these calculations. I hope you find the videos useful, and I will see you again. Thanks.